else troponin, whatever, okay? So that's not the point of this. The point is that myosin head is unable to bind to actin because there's this thing blocking it, okay? The way to get this thing to move is when calcium enters the cell and it binds to troponin C, so if we call this one troponin C, it's going to change the charge distribution of this whole complex, okay? Calcium has 2+ charges. When it binds, it's going to change the charge distribution of this complex, all right? This is a complex of proteins. When the charge distribution on a complex of, when the charge distribution of proteins changes, it causes the proteins to shift their shape, all right? So, calcium binding to troponin C causes this whole complex to shift, which then allows the underlying actin to be exposed and the myosin head to bind, okay? So that's what we're looking at here. So I just removed it all, but that's what I'm trying to illustrate. This has shifted, exposing the underlying actin. The myosin head is now able to bind, okay? So, problem is it's going to remain bound until something happens. And that something is ATP has to break that bind. So, here we have, just draw it in right here. When ATP comes, ATP, and binds to the myosin head, again, this has a certain charge, protein, will shift that shape, okay? Causing the myosin head to break free from the actin, kind of cock back.